Appium is a widely used open-source framework for automating mobile applications on iOS and Android platforms. It supports native, hybrid, and mobile web applications and allows users to write tests using a variety of programming languages such as Java, Python, Ruby, C#, and JavaScript. One of Appium's key advantages is that it leverages the underlying platform's automation libraries, like Scutis for iOS and UI Automator 2 for Android, enabling it to execute real device and simulator-based testing. To provide a complete understanding of Appium, including integration with CI/CD pipelines using Jenkins, this guide will cover the following: 1. Overview of Appium 2. Architecture of Appium 3. Features of Appium 4. Supported platforms and languages 5. Setting up Appium 6. Writing test scripts with Appium 7. Appium desired capabilities 8. Appium for native, hybrid, and web apps 9. Integrating Appium with Jenkins, CI/CD 10. Configuring Jenkins for Appium tests 11. CI/CD pipeline for mobile automation using Jenkins 12. Best practices for Appium and Jenkins integration 13. Common challenges and solutions 14. Conclusion 1. Overview of Appium. Appium is designed for automating mobile apps across different platforms. It uses the WebDriver protocol, just like Selenium, to interact with applications. By writing tests in a single language, users can run them across multiple devices and platforms, which makes Appium a flexible and powerful tool for mobile automation. Key advantages include cross-platform support, one codebase for iOS and Android, no app modification. Appium does not require source code modification or recompilation, multiple language support. Test scripts can be written in many popular programming languages. Open source. Appium is free to use and has a strong community. 2. Architecture of Appium. The Appium architecture is based on the client-server model. Here's an overview of the components. Appium server. The server acts as a middleman between your test scripts and the mobile device. It receives WebDriver requests from the client, translates them into platform-specific commands, like UI Automator 2 for Android or Scutis for iOS, and sends them to the device. The server then returns the response back to the test script. Appium client. This is where the test script resides. The client sends HTTP requests, based on the WebDriver protocol, to the Appium server. Mobile device. The device or emulator where the application is being tested. Workflow 1. The client sends a command, e.g., tap this button, to the Appium server. 2. The server forwards this command to the mobile automation framework, Scutis/UI Automator 2. 3. The framework interacts with the mobile application. 4. The result is sent back to the server and then to the test script. 3 features of Appium. 1. Cross-platform testing. Appium allows you to run the same test scripts on both Android and iOS, reducing code duplication. 2. Support for multiple app types. Automates native apps, built using platform SDKs, hybrid apps, combination of web and native views, and mobile web apps, websites accessed through mobile browsers. 3. No app modification. Appium does not require any modification of the application's code, like inserting test hooks. It automates apps as they are. 4. Language agnostic. Write tests using any WebDriver-compatible language, Java, Python, Ruby, JavaScript, etc. 5. Extensibility with plugins. You can enhance Appium's functionality using plugins. 4. Supported platforms and languages. Operating systems. iOS using Scutis, Android using UI Automator 2, Windows via WinAppDriver. Programming languages. Java, Python, Ruby, JavaScript, Node.js, C#, PHP 5. Setting up Appium. Setting up Appium requires installing both the Appium server and the necessary mobile drivers. Here's a basic setup. Step-by-step setup for Appium. 1. Install Node.js. Appium is built on Node.js, so install it on your system first. Bash sudo apt install Nodages Linux brew install Node Mac 2. Install Appium via npm. Use npm, Node's package manager, to install Appium globally. Bash npm install Appium 3. Install Appium Desktop. Optional. Appium Desktop is a GUI application for running Appium server locally, inspecting apps, and running tests. Download from https://github.com/appium/appium-desktop 4. Install mobile automation tools. For iOS. Install Xcode and enable Scutis. For Android. Install Android Studio, SDK tools, and configure UI Automator 2. 5. Start Appium server. To start the server, run bash Appium. This will launch the server on localhost 4723, ready to accept requests. 6. Writing test scripts with Appium. You can write test scripts for Appium using Selenium WebDriver libraries. Here's an example in Java for Android automation. Java import io.appium.dev_client.mobile import io.appium.client Android driver, import or.apinka.selenium.remote desired capabilities, import java.net URL, public class Appium test, public static void main string, args, throws exception, desired capabilities equals new desired capabilities, capabilities.set capability, platform name, Android, capabilities.set capability, device name, pixel_3" capabilities.set capability, app, /path/to/app. APK. Android driver mobile element, driver equals new Android driver, new URL, http://localhost, 4723/wd/hub, capabilities, mobile element L equals driver.find element by ID, com.example, ID/button, L.click, // example action driver.quit. 7. Appium desired capabilities. Desired capabilities are key value pairs that define the properties of the device or emulator and the app to be tested. Common desired capabilities for Android, platform name, Android, device name, pixel_3, app, /path/ to /app apk, automation name, UI Automator 2, app package, the package name of the app, optional, app activity, the activity to start, optional, common desired capabilities for iOS, platform name, iOS, device name, iPhone 12, automation name, SKUdist bundle ID, the bundle ID of the app, optional, UDIT, unique device identifier, for real devices, 8. Appium for native, hybrid, and web apps. Native apps, built using platform-specific SDKs and automated by interacting with UI elements. Hybrid apps, contain both native and web components. Appium can switch between the native and web context to interact with elements. Mobile web apps, for mobile browsers, Appium can automate browser interactions using Chrome driver for Android and Safari driver for iOS. 9. Integrating Appium with Jenkins CI/CD. Why Jenkins for CI/CD with Appium? Jenkins is widely used to automate software build, test, and deploy pipelines. Integrating Jenkins with Appium allows for automated mobile testing, triggered by code changes or scheduled events. Steps for integration. 1. Install Jenkins. Install Jenkins locally or set up a Jenkins server. You can download it from https://jenkins.io/download. 2. Install required plugins. Install the Appium and Selenium plugins, if applicable. Install the Git plugin if your code is stored in a Git repository. To install, go to Manage Jenkins-Manage Plugins. Search for Selenium and Appium plugins and install them. 3. Configure Jenkins job for Appium. Step 1. Create a new job in Jenkins. Step 2. Choose Freestyle project or a pipeline project depending on the need. Step 3. Under the Build Environment section, ensure that necessary environment variables are set, e.g., $android_home, $java_home, etc. Step 4. Set up a build step to execute your Appium tests. This could involve running a maven/gradle command for Java, or invoking a shell/batch script. Example shell command. Bash start Appium server Appium and run test mvn clean test. Step 5. Configure post-build actions such as publishing test results or sending notifications. 10. Configuring Jenkins for Appium tests. To run Appium tests as part of your CI pipeline, configure Jenkins as follows. Environment setup. Ensure that Appium, Node.js, Java, Android SDK, and Xcode for iOS are installed on the Jenkins build node. Node allocation. Use the Jenkins node allocation feature to run mobile tests on specific nodes with the necessary device emulators or real devices. Test reports. Use Jenkins plugins like JUnit to publish test results and failures. 11. CI/CD pipeline for mobile automation using Jenkins. A typical CI/CD pipeline for mobile automation with Jenkins may look like this. 1. Code changes. Developer commits changes to the version control system, Git, GitLab, Bitbucket, etc. 2. Build trigger. Jenkins triggers the pipeline. 3. Run tests. Jenkins initiates the Appium tests, using emulators or real devices. 4. Test reporting. Test results pass/fail are collected and reported back to Jenkins. 5. Notifications. Jenkins sends notifications via email, Slack, etc., based on the results. 12. Best practices for Appium and Jenkins integration. 1. Parallel execution. Use tools like Selenium Grid or Appium Grid to run tests in parallel across multiple devices. 2. Stability. Ensure stable device or emulator availability to avoid test failures due to connectivity or performance issues. 3. Environment management. Manage Android/iOS SDK paths, environment variables, and device configurations on the Jenkins node. 4. Dockerize the setup. Containerize your Jenkins and Appium setup using Docker for consistent builds across environments. 13. Common challenges and solutions. 1. Device unavailability. Solution. Use a device farm like BrowserStack or Sauce Labs to ensure reliable access to multiple devices. 2. Test flakiness. Solution. Stabilize tests by adding explicit waits and ensuring the app is in the right state before executing actions. 3. Long test execution time. Solution. Break tests into smaller suites and run them in parallel on multiple devices or emulators. 14. Conclusion. Appium is an incredibly versatile tool for automating mobile applications, offering flexibility, multi-platform support, and integration capabilities with various CI/CD tools like Jenkins. By integrating Appium into your CI/CD pipeline with Jenkins, you can create a robust, automated process for testing your mobile applications, ensuring faster delivery with higher quality. However, it's essential to adopt best practices to handle challenges like device management and test stability effectively.